Hi everyone, here I'm going to demonstrate a poor man's version of the Barbosa and Lau ground energy captor. And we're going to start with the grid right here. That is a receptacle with 120 volts, 60 hertz grid power there. And just connected the kilowatt meter, and you can see there's the voltage. And now that's the power factor. That is the frequency, that is volt amps, that is watts, and that is amps. So I'm going to be plugging in this wire in there as the, when we're going to utilize only the hot side of this wire here, which is connected to a receptacle here, one side of the receptacle, and the other side of the receptacle is connected to a ground. Now this ground was is independent than the grid ground, and what it is, when this whole building, this is a large building here, large garage, was built, this is attached to the whole reinforcing rebar of the whole cement floor foundation of this building. So it's a large surface area. It's a two-car wide garage. And like I said, it's attached to the rebar of the garage. So that is it. That's all you need. This is our power meter that we're going to check our output and how many watts we're getting free from the ground here. Okay, and then we're going to check in how many watts is coming in from the grid. So this is a quick, simple replication of the device without going with exotic transformers. And we're going to see the same kind of effect happening. So here we're going to plug in this bulb here. This is a halogen bulb, and I believe it's 72 watts at 120 volts. And we're going to put our meter here on watts. So there it is on watts, and we're going to plug that in, make sure that our meter is working correctly. And our meter is obviously displaying 72.6 watts there. So we know that's working correctly. And obviously you can see the bulb is on. Okay, so that's off. And now what we're going to plug in is our power lead here, going to the Barbosa energy captor. And we can see there it's taking 0 watts from the grid. And you can see now our other kilowatt meter here is on. We have 120 volts there, and we're going to switch that up to display watts. There it is on amps, and there it is on watts. I have a clamp on amp meter here. We're going to also check how many amps we're going to get from the ground. We'll attach that once we attach our load here, and let's see if we get some power out of this. So here I am plugging in, trying to do this with one hand here, plugging in our bulb the right way. Okay, so there's our bulb plugged in, and we can see we're pulling 50 watts, not as much as the directly from the grid. Okay, and the reason for that is there is resistance. This is not like a zero resistance or a very low resistance ground system. I've verified the resistance on that, and it's around 45 ohms of the resistance on that particular ground. But it's just to demonstrate the effect. The less resistance you have on your ground, the better power you're going to have, be able to capture from the ground. Okay, and let's put on our clamp meter here for checking the amount of amps. And there we are, pulling 0.4 amps from the ground through the system. And now the important part, we go to our watts meter, and how much are we pulling from the grid? Apparently 0 watts. So, is this free energy? You decide. I'll pull it out. See the bulb? I've pulled that out. Stops. Connect it back. You see we have the 120 volts. Our bulb is lit. And we have here 95 volts across our bulb, again because part of the voltage is going in the resistance in the ground system. And if we go to watts, we have 50 watts there. And now if we go to how many watts we are pulling from the grid, 0 watts. So there you go. That is the Barbosa Enlil device for the poor man. And you figure out if you think this is real. Thanks. Bye.